Hello students, I'm Dr. Seema Singh and you're watching my channel Bonding with Chemistry. I know this video is much delayed. Actually, I was busy with the launch of my new YouTube channel for kids named Guglu Giggles as a gift for my son, whom I lovingly called Guglu. In case you want to have a look at its introductory video, you can click the link provided on the top. I promise it will definitely make you smile, and there is nothing more special than starting this video with a smile on your face. Coming back to class 9 chemistry, we'll continue with part 4 of the chapter Matter in Our Surroundings. Let me remind you that this chapter stands deleted due to COVID-19 for students who will be taking their annual examination in the year 2021. Please refer to the video link provided in the description box for more information on the revised CBSE syllabus for class 9. As already stated, I would be covering all the topics from all 4 chapters of chemistry, including the deleted portions, so that you do not face any kind of problem in grasping concepts in your current as well as in your higher classes. So don't forget to subscribe to my channel and do please hit the bell icon for receiving the latest updates. In today's video, I'll take up the first part of the topic, whether the state of a matter can be changed. In my upcoming video, I'll take up its second part. These are the list of topics that I've already covered in my previous videos, whose links you can find in the description box below. Dear students, let's get started. Before I answer the question, can matter change its state? Let us understand what the statement actually means. Let me explain this with a simple everyday example. All of you use water, right? In which state you use it maximum? Liquid? Correct. Does it exist in other physical states? Yes. Water exists in the form of solid ice as well as gas or water vapors, also called as steam. Dear learners, there actually is a difference between gas and vapors, but most of the times these terms are used interchangeably, and so for your class level, we too will be using these two words interchangeably. Now, to obtain ice from water, we freeze water in a refrigerator, and for obtaining steam, we boil water. I'm sure you know that the steam generated in your pressure cooker is responsible for cooking rice, vegetables, pulses quickly. So these are the 3 states of water. Ice, the solid form; water, liquid; water vapor or steam or gas is the gaseous form of water. Let us come back to the question, can matter change its state? Yes, of course. Matter can change its state. The next question we need to address is, how can we change the state of a matter? The physical state of a matter can be changed in 2 ways. 1, by changing the temperature, and 2, by changing the pressure. In this video, I'll take up the first method of changing state of matter, that is change in temperature. How a change in pressure can lead to a change in state of a matter will be dealt in my next video, that is the second part of this video. So don't forget to hit the bell icon for receiving updates from my channel. Coming to the first method, we just learned that by cooling or heating water, we can change its state from liquid to solid ice and water vapors respectively. This means by changing the temperature, we can change the state of a matter. To understand this, let us undertake a simple activity. The aim of the activity is to study the effect of change of temperature on the physical state of ice and liquid water. The first part of the activity is also an experiment that is performed to determine the melting point of ice, whereas the second part helps in determining the boiling point of water. My dear students, this activity is very important. Not because it is difficult to understand or perform in the laboratory, but just because through this activity, I will be introducing few important concepts or terms that you will be using not only in your present class as well as in your higher classes, but also in your everyday life. For the first part of this activity, which is determining the melting point of ice, we take some crushed ice in a beaker and suspend a thermometer into it in such a manner that its bulb is in contact with the ice as shown here. Obviously, a thermometer is going to help you record or measure the temperature. We note the temperature of the ice. And what do you think the temperature will be? It will be 0 degrees Celsius. We will now heat the beaker gently on a low flame. What will we observe? We will observe that the ice starts melting into water. We will also keep an eye on the thermometer and note the temperature. We observe that as more and more heat is supplied, more ice keeps on melting. But now this part is important. But the thermometer reading is constant at 0 degrees Celsius, and it remains this way until the entire solid ice has converted into liquid water. Once all the ice has melted, then on further heating, the temperature starts rising again. And that will begin the second part of the activity, which is determining the boiling point of water. For this part of the activity, we further heat water while constantly stirring it with the help of a glass rod or a stirrer. We also keep a careful watch on the thermometer reading and observe that as the heat is provided, the temperature of water gradually increases until it reaches 100 degrees Celsius. At this temperature, the water begins to boil and convert into steam. Although with more heat, more steam is generated, but the thermometer reading remains constant at 100 degrees Celsius until the entire water has converted into steam. My dear students, if you look at this figure, you will see that while determining the boiling point of water, the bulb of the thermometer is kept above water by 1 to 2 centimeter. This is because we are going to measure the boiling point of steam that is generated or the water vapor that is generated. In most of your textbooks, including NCERT, the bulb is shown dipping inside the water, which practically is incorrect. So please be careful while performing this experiment in your laboratory. Now let us look at the various conclusions that we arrive from this activity. The first being, by increasing the temperature, that is by providing heat, a solid can be converted into a liquid and a liquid can be converted into a gas. The process in which a solid converts into a liquid on heating is known as fusion or melting, and the process in which a liquid converts into a gas on heating is known as boiling. So you have learned two terms, melting, also known as fusion, and the other is boiling. We also saw in this activity that there were 2 points in the thermometer when the temperature remained constant. One, during the entire process of melting of ice, and second, during the process of boiling of water. We observed that the melting of ice into water took place at a fixed temperature of 0 degrees Celsius. This fixed temperature is known as the melting point of ice. For any solid, the melting point is defined as the temperature at which a solid substance melts and changes into liquid at atmospheric pressure. By atmospheric pressure, I mean the force exerted on the surface by the atmosphere or the air present above it due to the gravitational pull of the earth. It is also called as air pressure, and it is commonly measured with the help of an instrument known as barometer. My dear learners, a very important point that you need to remember and keep in mind is that melting point is also the temperature at which solid and liquid phases of a matter coexist. For example, at 0 degrees Celsius, if I ask what will be the physical state of water, you're going to write that water is going to exist as solid as well as liquid. Both states are going to coexist, ice as well as water in the liquid form. The reason behind the coexistence of solid and liquid phases you're going to learn in your higher classes when you will study the topic equilibrium. Let us learn more about melting point, which is abbreviated as m.p. The melting point of a pure solid is fixed. That means pure ice will have a melting point of 0 degrees Celsius. But if there is an impurity in the ice, say in the form of salt, etc., its melting point will differ. More about it you will learn in your higher classes. The next point is different solids have different melting points. For example, wax has a melting point between 60 to 65 degrees Celsius depending on the type of wax. The melting point of pure gold is 1064 degrees Celsius, whereas iron melts at a temperature of 1538 degrees Celsius. Don't worry, you don't have to learn these values. They're only for your extra additional knowledge. Another important point is melting point is a measure of force of attraction between the particles of a solid, which means higher the melting point, greater is the force of attraction between the particles of a solid. For example, iron has a melting point of 1538 degrees Celsius, which indicates that the force of attraction between the atoms of iron is very strong. And in order to melt iron, this force has to be broken by supplying a greater amount of heat in comparison to wax. Wax has a melting point between 60 to 65, so it has weaker force of attraction between particles as compared to iron. So in order to melt wax, you have to supply lesser heat energy as compared to melting of iron. Let us now understand the reason behind the temperature remaining constant at 0 degrees Celsius until the entire ice melted in this activity. Dear students, this is an interesting part because we were continuously supplying heat in this activity. And when you heat a substance, you obviously expect the temperature to rise. But here we observed that even though heat is being supplied continuously, thermometer indicated a constant temperature of 0 degrees Celsius. To understand this, we need to know what happens at microscopic level when you heat ice or for that matter any solid substance is melted or fused. We can recall from our previous videos that in a solid, the particles are held together by very strong forces of attraction and they have minimum kinetic energy. We also studied that kinetic energy is directly proportional to temperature. When you increase temperature, the kinetic energy of the particles also increases. We also learned that in a solid, the particles vibrate at a fixed position. Now, when we heat a solid, the heat energy increases the kinetic energy of the particles and in turn make these particles vibrate more vigorously. As you keep supplying heat energy, these vibrations also become stronger. At the melting point, the particles of a solid have sufficient kinetic energy to overcome the strong interparticle forces of attraction holding them in a fixed position. They break free. The interparticle forces of attraction weakens and the interparticle spaces increases and eventually solid melts to form a liquid. Coming back to the same question which I'm going to mark as important. Why doesn't the temperature change until ice melts completely even though heat is being supplied? Where does this heat energy go? Now you have the answer. This heat energy is used in overcoming the forces of attraction. I mean, the heat you supply is used to break the strong forces of attraction between the particles of a solid. Dear learners, Note that this heat is now not being used in increasing the kinetic energy. Okay? It is only being used to loosen the forces between the ice particles. And since kinetic energy is not increasing, your temperature also remains constant at 0 degrees Celsius in case of melting of ice. This heat energy, which is going into the ice but is not increasing its temperature, is being used to convert the state of ice from solid to liquid water and is known as latent heat of fusion or latent heat of melting. Actually, the term latent was introduced around 1762 by a British chemist, Joseph Black. It is derived from the Latin word latere, which means to lie hidden. I'm sure you can answer why latent heat of fusion or melting is called as hidden heat. This is because the heat supplied is being absorbed by the ice without showing any rise in temperature. It seems that the heat is hidden somewhere in the contents of the beaker. Coming to the definition of latent heat of fusion, which is an important definition, it is defined as the quantity of heat in joules, the unit for heat, required to convert 1 kg of a solid into liquid when at its melting point and at atmospheric pressure without any change in temperature. Always remember, latent heat does not cause a rise in the temperature of a substance because this heat is used to loosen the force between the particles of a solid so that they can be converted into liquid. For example, the latent heat of fusion of ice is 3.34 into 10 raised to the power 5 joules per kg, which means that 3.34 into 10 raised to the power 5 joules of heat energy has to be supplied to convert 1 kg of ice at 0 degrees Celsius at atmospheric pressure to water. Clear? Don't worry students, you don't have to learn this value. It is just an example for providing better clarity to the concept of latent heat of fusion. Let us now move on to the conclusion derived from second part of the activity. When all the ice has melted to water, then the heat energy which is supplied to water is again used to increase the kinetic energy of the particles. And when the kinetic energy of the particles will increase, what is going to increase? The temperature is going to increase. And this is what you observe when all the ice has melted. The temperature starts rising again until it reaches 100 degrees Celsius in case of water. At this temperature, the particles gain enough energy to break free from the forces of attraction present in liquid water and convert to gaseous or vapor state. That is, water begins to boil. We have just studied that the process in which a liquid converts into a vapor or gas by heating is known as boiling, and the temperature at which a liquid boils and converts into vapor or gas at atmospheric pressure is known as boiling point of a liquid, abbreviated as B dot P dot. Also remember that boiling point is the temperature at which the liquid and gas phases of a matter coexist. So if I put up a question that at 100 degrees Celsius, what will be the phases in which water exists? It is going to exist in both liquid as well as gas phases. Boiling point is fixed for a pure liquid. If your water is pure, it is going to boil at 100 degrees Celsius. If it is impure, it is going to boil at a different temperature about which you will study in your higher classes. Just like melting point, different liquids have different boiling points. For example, pure water boils at 100 degrees Celsius, mercury boils at 356.7 degrees Celsius, alcohol at 78 degrees Celsius, etc. Don't worry, these are just examples. You need not learn the values. Just like melting point, boiling point is a measure of force of attraction between the particles of a liquid. I'm sorry, instead of word solid, you are supposed to have here liquid. So higher the boiling point, greater will be the interparticular force of attraction in a liquid. Just as we observed in the case of melting, during the process of boiling also, we observe that until the entire water vaporizes, the temperature does not increase and remain constant at 100 degrees Celsius even though there is a continuous supply of heat energy. Now I'm sure you can reason out where that heat energy, which seems to be hidden, actually is being used. Yes, it is being used in overcoming the force of attraction between the particles of water so that they can convert into vapor form. This heat energy is known as latent heat of vaporization and is defined in a similar manner to latent heat of fusion. It is the quantity of heat in joules required to convert 1 kg of a liquid at its boiling point and at atmospheric pressure to gas or vapor without any change in temperature. For example, latent heat of vaporization of water is 22.5 into 10 raised by 5 joules per kg, which means 22.5 into 10 raised by 5 joules of heat energy is required to convert 1 kg of water into water vapor at its boiling point of 100 degrees Celsius and at atmospheric pressure. So my dear learners, from this activity you learned what is melting, also known as fusion, what is boiling, melting point, boiling point, and two types of latent heat. One, latent heat of fusion, and the second one, latent heat of vaporization. Moving ahead, let us learn about few more processes. Actually, the reverse of these two processes. If on supplying heat, we can change solid to a liquid and a liquid to a gas, can we do the opposite by lowering the temperature or cooling, converting a gas to a liquid and a liquid to further solid? Yes, of course. If we cool the vapors or the steam by lowering the temperature, it gets converted into liquid water. For example, you would have observed if a glass of hot milk or tea is covered with a lid and the lid is lifted after some time, tiny droplets of water are formed on the inner surface of the lid. This happens because when hot water vapor present in tea or milk touch the cool surface of the lid, they lose their kinetic energy. Remember, kinetic energy is directly proportional to temperature. So when they touch the cool surface, temperature lowers and hence the kinetic energy. And finally, these particles come closer to each other and start getting attracted with a greater force of attraction and eventually get converted to liquid state. This is exact opposite of what happens during boiling. And this process of changing a gas to a liquid by cooling is known as condensation. Moving on to the next part, converting a liquid into a solid. When we freeze liquid water by keeping it in freezer, it changes to solid ice. This process of changing a liquid into a solid by cooling is known as freezing or solidification. It is the exact opposite or reverse of melting. Now what happens when the temperature of a liquid is lowered? For example, let us take water. As you lower the temperature of water, the kinetic energy of the liquid molecules lowers, and at one particular or fixed temperature, which is 0 degrees Celsius, the liquid gets sufficiently cooled that the particles stop moving and only vibrate about their fixed position and thus eventually convert into solid ice. Let us summarize all the processes that we have learned until now with the help of a flow diagram. You can see here, solid converts into liquid, the process is known as melting or fusion. Liquid converts into gas, the process is known as boiling. The reverse processes are known as condensation and solidification respectively. Now, my dear student, is it possible to skip the second step? I mean, can we convert a solid directly into gas or vapors without passing through the liquid state? Yes, we can. And the process of changing a solid directly into vapors by heating, or the conversion of vapors into solid directly on cooling without passing through the liquid state, is known as sublimation. I can diagrammatically show sublimation as solid being converted into a gas being converted into solid. Solid to gas you can convert by heating, whereas gas to solid you can convert by cooling. Both these processes are known as sublimation. Also, the conversion of gas into solid is called as reverse sublimation or deposition. So you can call the process of converting gas into solid on cooling without passing into liquid state as sublimation, reverse sublimation, or deposition. Students, you must have come across the process of sublimation at your home. The naphthalene balls, commonly known as mothballs. They are used to repel insects. These balls, which your mother generally keep in cupboards while storing woolen clothes to protect them from the attack of moth or insect, disappear after some time. They don't leave a trace or a residue of a liquid. They simply undergo sublimation. These balls slowly keep forming naphthalene vapors that disappear in air. Another common example of a solid undergoing sublimation is camphor, which is also called kapoor in Hindi and is used during puja and religious ceremonies. These are some more examples of substances that undergo sublimation. Let us undertake an activity that demonstrates the process of sublimation. For this activity, we take small amount of ammonium chloride in a china dish. Ammonium chloride is a chemical that is easily available in science laboratory and is white in color with the formula NH4Cl. You're going to cover the china dish with an inverted glass funnel as shown in this figure. A cotton plug is loosely put in the hole or the open end of the stem. Now this is the funnel. This portion is known as stem of the funnel. So you're going to block the stem of the funnel, the hole which is present here, with the help of a cotton plug. This is done so that the vapors of ammonium chloride do not escape into the atmosphere. Now we slowly and carefully heat the china dish with the help of a Bunsen burner and make our observations. We observe that on being heated, ammonium chloride solid directly converts into white color vapors. These vapors rise up, and as they cannot escape from the funnel end, they convert into solid ammonium chloride. And why do they convert into solid ammonium chloride? This is because they come in contact with the cold inner walls of the funnel, and thus the vapors convert into solid without passing into the liquid state. We can see here ammonium chloride has undergone sublimation on heating, converting directly into gaseous phase, and on cooling the vapors again converted into solid ammonium chloride. The solid that undergoes sublimation, in this case ammonium chloride is the solid which is undergoing sublimation, is said to sublime. Ammonium chloride sublimed, and the solid obtained by cooling the vapors of the same solid. Ammonium chloride vapors were formed, they rose up, and again they solidified. This solidified ammonium chloride is known as sublimate. So ammonium chloride sublimes to form ammonium chloride sublimate due to the process of sublimation. Another very important example of a solid that sublimes is dry ice. Now dry ice is not solid form of water, but it is the solid form of carbon dioxide having the formula CO2, and here you are supposed to write the state which is solid. At times you might get a question, what is dry ice? Why is it so called? Now you know the first part. This is the answer to the first part. Why is dry ice so called? It is so called because dry ice directly converts into gaseous form. So you have CO2 solid subliming and converting into CO2 gaseous. It does not pass through the liquid phase like your ice. If you have ice formed from water, it is going to melt into liquid and thereafter convert into gas form. Since it does not pass through the liquid state, it is called as dry ice because the word liquid is synonymous to wet. Coming on to the application of dry ice. Dry ice is commonly used by most of the vendors selling ice cream in their carts. It helps in keeping the ice cream frozen without refrigeration. When you place dry ice in water, suppose you have water and you place dry ice, its rate of sublimation is going to increase and it converts into vapors that are low sinking. Vapors will lie near the surface and they create dense cloud of smoke like fog. This finds use in creating special effects in theaters, movies, live concerts, and nightclubs where a dramatic, fog like heavenly or haunted effect has to be created. You must have seen such effects created using dry ice in stage shows, movies, etc. The various processes reflecting the interconversion of the three states of matter can be diagrammatically illustrated with the help of this figure, which is known as states of matter triangle. In case you are short of time and you need to revise or recall the entire topic, you can quickly go through this figure. Here you can see that I have mentioned a word evaporation, illustrating the state change from liquid to gas along with boiling. We'll learn more about this term and the difference between boiling and evaporation in one of my upcoming videos. My dear students, let us finally put to test what we have learned by answering the following NCERT questions. As always, I'll advise you to try and answer these questions by considering it as a 15 to 20-minute revision test. In case you get stuck up, you can always look at the answers and the explanation that I have provided. In these questions, I'll also take up two important hot questions. So let us begin with the first question. What is the physical state of water at 250 degrees Celsius? Obviously, it is greater than 100 degrees Celsius, so your water is going to exist in the form of gas. 100 degrees Celsius boiling point, vapors and liquid state coexist. So you will have water in the form of gas also as well as liquid at 100 degrees Celsius. Here is the answer for you to check. Coming on to the next question, for any substance, why does the temperature remain constant during the change of state? I told you during the change of state, let us say melting or boiling, heat is used up in overcoming the interparticle forces of attraction. It is not being used in increasing the kinetic energy. And if kinetic energy is not increasing, obviously temperature will not increase and you will see that temperature remains constant. Here is the answer. Give reason for the following observation. Naphthalene balls disappear with time without leaving any solid. This is because naphthalene balls undergo sublimation. They change into vapors directly at room temperature, thus they disappear without leaving any solid residue. Here is the answer. Moving on to the next question. What is the physical state of water at 25 degrees Celsius? At 25 degrees Celsius, water is going to exist in liquid state. At 0, it is melting point. So solid and liquid state are going to coexist. This part we've already done. So here is the answer. Moving on to the next question. Name A, B, C, D, E and F in the following diagram showing change in its state. I will suggest students you can look at the states of matter triangle and complete this diagram. Moving ahead, let us do two important reasoning or HOTS questions. These questions are applicable in your practical or everyday lives too. The first being, why is ice at 0 degrees Celsius more effective in cooling than water at the same temperature? Now students, try and understand this. You have ice, water, solid form ice. If you have to convert it into liquid form, you need to provide heat, and this heat is known as latent heat of fusion. Suppose you have burn injury on your hand, right? This is the wound. Now when you rub ice, this is the ice cube. Suppose you rub ice will melt into water. For melting this ice, you have to provide this heat, and this heat is provided by this burn injury. So this ice takes up heat from this burn injury and convert into water. Since this ice is taking up heat, it causes cooling sensation. And thus, ice at 0 degree is more effective in cooling than water at 0 degree because the energy possessed by ice is lower than that of water. Moving on to the last question, what produces more severe burns, boiling water or steam? Again, let us understand in a similar manner. We have water in liquid form. When you will supply heat, it will convert into gaseous form or steam. And this heat is known as latent heat of vaporization. So your gaseous form has more energy in the form of latent heat of vaporization as compared to liquid water, and thus steam will produce more severe burns. With this, my student, I come to the end of this video. In this video, we learned that the state of a matter can be changed by changing the temperature. The state of matter can also be changed by changing the pressure, about which we will learn in my upcoming video. So hit the bell icon for receiving the latest updates and kindly subscribe to my channel. In case you like this video of mine, do please spare a moment and hit the like button. Above all, if you think this video can help a learner perform better, don't forget to share. Thanks for watching, and until we meet next, take care and stay bonded, my dear learners.